Dear friends, welcome to Bond with RP Chemistry YouTube channel. In this video, I am going to explain the multiple selection questions which are appeared in JAM 2020-21 chemistry question paper. The first question, the complexes that show John-Taylor distortion are. John-Taylor distortion, this one, is exhibited by the complexes which are non-linear, in which the metal has degenerate states with asymmetric electronic configuration. Asymmetric electronic configuration. Okay, let's take the first complex. Here the oxidation state is +2. Here the +4 oxygen state. This one is +2, and this one +3 oxidation state. In cobalt 2 plus, the electronic configuration is D7, strong field ligand. In octahedral, there is a splitting of 5d orbitals into T2z and EZ set of orbitals. Since Cn minus is a strong field ligand, there is a large gap between 2Tz and EZ. The 7 electrons will be filled, 1, 2, and 3. Next, there is a pairing, 6 electrons, and this one is 7. So this electronic configuration, this one is symmetric electronic configuration. This one, asymmetric electronic configuration. Here you have two degenerate states. One has 1 electron and another one has 0 electron. So it's asymmetric electronic configuration. Here cobalt 2 plus, that is the D7 electronic configuration, strong field ligand. It has asymmetric electronic configuration, so it can exhibit a John-Taylor distortion. Ni4 plus, the electronic configuration is D6. It's a weak field ligand. There are also T2Z and the EZ set of orbitals. 1, 2, 3, 4, 5, and this one is 6. T2Z. If you take T2Z, here you have 2 electrons, 1 electron, and 1 electron. Here there is a asymmetric distribution of electrons. So this one can exhibit John-Taylor effect. Mn2 plus, strong field ligand. Mn2 plus, it's a D5, strong field ligand, and this is the distribution of electrons. 1, 2, 3. In terms of strong field ligands, there is a pairing of electrons. Here there is a asymmetric distribution of electrons, so it can exhibit John-Taylor distortion. CO cobalt, COEN twice F2 plus, here cobalt has +3 oxidation state. In cobalt 3 plus, the electronic configuration is D6, and these are strong field ligand. En is strong field ligand, so the 6 electrons will be filled. There is a pairing of electrons, 4, 5, and 6, 2, 2, 2. Here there is no asymmetric distribution of electrons. There is a symmetric electronic configuration, so this one cannot exhibit John-Taylor distortion. So complexes 1, 2, and 3, these 3 complexes can exhibit John-Taylor distortion. Among the following, the anti-aromatic compounds are. Okay, according to Huckel's rule, the cyclic compounds, which are cyclic, planar with 4 and pi electrons. 4 and pi electrons are anti-aromatic, and 4 and plus 2 pi electrons are aromatic, anti-aromatic. So here, this one is planar, cyclic, planar. It has 4 pi electrons. So this one is anti-aromatic. This one also cyclic, planar, 4 pi electrons, aromatic. This one also cyclic, planar, and here you have 8 pi electrons. This one belongs to 4 and pi system, so this one also anti-aromatic. Here, this carbon This one is sp3 hybridized carbon. So this cyclic structure is non-planar. It's not planar molecule. It's a non-planar. So this one is non-aromatic. When the cyclic molecule is non-planar, the molecule will be non-aromatic. So which are anti-aromatic? 1, 2, and 3. These three are anti-aromatic. The correct statements about sodium nitroprusside. Sodium nitroprusside, this is the formula Na2Fe CN5NO. Here NO, this one is in the form of NO plus. It's a nitrosyl ligand. This one is correct. It is used for the detection of S2 minus. So when you treat with S2 minus, this one will become Na2FeCN5NOS2 minus. Okay, this complex is in violet color. So this test is used for the detection of sulfur. Okay. Second one is also correct. And third one, nitroprusside ion is formed in the brown ring test. Actually, in brown ring test, you can find FeH2O5NO2 plus. This is a complex which is formed in the brown ring test. So this one is incorrect. It's a paramagnetic complex. Let's take this complex. In this complex, let's take the oxidation state of iron as X, and this one CN5, 5 into minus 1, and the NO plus 1 is equal to, the charge on the complex is minus 2, so it's equal to minus 2, X is equal to plus 2. So Fe plus 2, strong field ligand, Fe2 plus, 3,6 electronic configuration, strong field ligands. So there is a pairing of electrons takes place in T to Z. So all electrons are paired. So it's a diamagnetic, not paramagnetic. This one is diamagnetic. So this one is incorrect. So what are the correct options? First one and second one. These are correct options. The correct statements about this species are isoelectronic. These are not isoelectronic. Molybdenum and tungsten, these two have different number of electrons. So these are not isoelectronic. And these are isolobal. Isolobal means they have same type of frontier molecular orbitals, similar frontier molecular orbitals with the same energy or nearly same energy, same shape, and also same symmetry and same radial distribution. So in case of CH3 and MnCO5, these are isolobal. Okay, CH3, this one has one frontier molecular orbital, and MnCO5, this one also has one frontier molecular orbital. So these are isolobal. Actually, CH4, this one is isolobal with CrCO6, and CH3 is isolobal with MnCO5, and CH2 is isolobal with the next element, chromium manganese, CO4, and CH is isolobal with the cobalt, CO5. BH and CH are isolobal and isoelectronic. BH and CH are not isoelectronic and also not isolobal. Here you have 6 electrons, here you have 7 electrons. These are not isoelectronic and isolobal. And CH2 minus and NH2, these are isolobal and also isoelectronic. Here you have 6 plus 2 plus 1, 9 electrons. Here you have 9 electrons, and also these are isolobal. They have similar FMOs with the same energy, shape, and symmetry. So these are isolobal and also isoelectronic. So which are correct statements? And second statement and fourth statement. Second and fourth statements are correct statements. The correct Maxwell relationship derived from the fundamental equations of thermodynamics is Okay, dou S by dou V at constant temperature is equal to dou P by dou T at constant V. Sp. Here there is a positive sign. This one is correct. And dou T by dou V at constant S is equal to dou P by dou S at constant V. Here Tp there is a negative sign. Here there is a negative sign. So this one is incorrect. And dou S by dou P at constant T is equal to minus dou V by dou T at constant P. This one is correct. And here there is a positive sign. So dou T by dou P at constant S, dou V by dou S at constant P, this one also correct. So 1, 3, 4 are correct statements. The pigment responsible for red color in tomato has one functional group. The correct statements about the functional group is are. Lycopene, this is a pigment which is present in the tomato. This lycopene molecule has 11 conjugated double bonds, and two isolated double bonds, In this molecule, you have only C double bond C functional group. No other functional group is present in lycopene. So the molecule lycopene can exhibit the tests of alkanes or C double bond C. It gives positive silver mirror test. Silver mirror test is exhibited by the aldehyde. So this one is not correct. It gives hydrazone derivative on reaction with 2,4-dinitrophenol hydrazide. This is the test for carbonyl compound. So this one is negative. It gets cleaved on reaction with ozone. We know that C double bond C. This one is cleaved. There is a cleavage of C double bond C in presence of ozone. And it decolorizes bromine water. Bromine water test, this test is for finding out unsaturation in the molecule. So C double bond C can exhibit decolorization of bromine water. So 3 and 4 are correct options. Hans pyridine synthesis involves several steps. Some of those are. Okay, these are the steps which are involved in the batch pyridine synthesis. Here, in this synthesis, we have to check beta keto esters, two molecules of beta keto ester. This one is beta keto ester, this one also beta keto ester, and one aldehyde and ammonia. Finally, we will get the pyridic derivative. Here, in first step, there is enolization. This enol form attacks on the carbonyl compound. So this one is aldol reaction, and here there is a condensation. So it's aldol condensation. And second, beta keto ester reacts with ammonia, and there is a formation of this molecule, and there is an attack of there is a 1,4 addition type. It's a Michael addition. Here there is a Michael addition, and finally you will get pyridine. So in this reaction, you can find aldol reaction and the Michael addition reaction. Dargen you cannot find, and also managed reaction you cannot find. So what are the correct options? 2 and 3, these two reactions are involved in the Hans pyridine synthesis. The compounds which give benzoic acid on oxidation with KMnO4 are. The KMnO4 oxidation with KMnO4, the benzylic group has proton, at least one proton. Then this one is oxidized by KMnO4 into benzoic acid. This is the benzoic acid you will get. Suppose if this molecule does not have alpha hydrogen, all are alkyl group, let us take R, in presence of KMnO4, this one will be oxidized. This ring will be oxidized, and there is a formation of CO, OH, and R. So here, this one will be converted into COOH. This one will be converted into COOH, and here this one will be converted into COOH. So finally, we will get here there is a COOH, and this one here also there is a COOH. So this one cannot form benzoic acid. This one has hydrogen, benzylic hydrogen. So this one will be converted into benzoic acid. Benzoic acid. Here also there is no proton at the benzylic position, so this one will not be oxidized into benzoic acid. Here actually you will get this compound. This is the compound you will get. Here you have benzylic hydrogen, so this one forms the benzoic acid. So this one cannot form, this one form, this one cannot form, this one can form. So what are the correct options? 2 and 4 can form benzoic acids. The products P and Q formed in the reaction node. Here we have taken trans alkyl. This is F1-Cl. This is the singlet carbene. Here there is a concerted addition reaction takes place. In concerted addition reaction, it's a stereospecific reaction. Here the methyl groups should be trans to each other. One should be above the plane, another one should be below the plane. Here both are above, so this one is not correct. Both are below, not correct. One is above, one is below. Here both are above, so this one will not be formed. Here one is above, one is below, and this one below, and this one is above. So only there is a formation of 4 compounds. The functional groups in reducing sugar that test positivity tolerance reagent is R. Okay, what are the functional groups which are positive towards the tolerance reagent? Okay, these are the functional groups. Aldehyde is positive, and also hemiacetal. This is the hemiacetal form, OH, and this one is OR. Hemiacetal, this one is positive, and also beta hydroxy ketone, this one also positive. Ketone cannot perform tolerance test, and also acetal, this is the acetal form, OR and OR. Acetal cannot form tolerance test. So MA-acetal and aldehyde can form tolerance test. So what is the correct options? 2 and 4 are correct options. Thank you. Thank you very much.